Okay, so today's date 6. Wow, 6/6, huh? 18. Hey, today in history is the day we did D-Day. It's the invasion of France to liberate Europe back in 1942, 41?
42.
Yeah, today's D-Day. So if you don't know what D-Day is, way back we had this war called World War II. We were at war with Germany and with Italy and with the Japanese. And today, in 1942, we started our taking back of all those countries. So today is D-Day, some 50 some odd years ago. Anyway. So Common Core Standard. So today we're talking about, we're going to be solving right triangles with trigonometry. Trigonometry. Okay, write that down. We're going to solving right triangles with trigonometry. Okay. So a couple of things I want to add to this. So you know, we're going to see these two words: angle of elevation. And we're going to see this term, angle of depression. Okay. Angle of depression, okay? So write those two terms down, angle of elevation and angle of depression, and we'll talk about it, okay? So every time we measure an angle, and we've done this outside, we always measure with the horizon, right? We've gone outside, you've measured so that your protractor is flat with the horizon, that's 0, right? So an angle of elevation would be the same way. An angle of elevation would be from 0 up. 0 degrees up. That's an angle of elevation from the horizon. Because when we're outside and we're measuring, we don't put 0 up here. That'd be silly, right? 0 is not up here. 0 is always on the horizon. And then we just measure up. Angle of elevation. Okay? Angle of depression is the same way. An example of angle of depression is if you're in an airplane and you're descending, your angle of depression is coming down from the horizon. So our angle of depression is the same thing, where we'd have our 0 degrees here, and our angle of depression is coming down, okay? So our angles are always measured from the horizon. Any kind of story problem, you take your protractor and you're measuring from horizon either up or your horizon down, okay? What confuses kids real quick, then I'll put on the side, is a question like this. I'll show you, okay? You would never use this in an angle of depression. This would be your angle of depression, right? Okay? This would not be an angle of depression. This would be your angle of depression because you go from 0 down, right? Some kids mistakenly use this, but you don't want to use this angle, okay? All right, so let's do example 1. This angle here? It'd be the other acute angle.
Oh, it'd just be like from 90 to that.
Yeah. Okay, example 1. Now remember, if we're going to do story problems, a lot of kids do not like story problems, but these are not that bad. Everything is going to be from a right triangle. So when we do these, let's read the problem and say, hey, I got to draw a right triangle. Once I draw the right triangle and label my right triangle, then I'm just going to use what's up on my board as far as notes, okay? So example 1, we have an air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. The pilot reports the plane's altitude is 4,000 feet. What is the horizontal distance between the plane and the airport? So let's draw a picture, okay? So let's draw a little airport control tower. Here's the guy. Here's my tower, and there's an airplane way up here is my airplane. Okay, there's my airplane, right? Yeah, there's my airplane. And so somebody's sitting in this tower, right? And they sight the airplane, right? And it's at an angle of elevation. So let me draw a right triangle. Okay, so let's just draw a right triangle. Okay, as long as we can draw a right triangle and come up with and put the numbers in the right place, we can do this. Okay, so I have my air traffic controller on the ground. The angle of elevation is 41 degrees. The height, the altitude, is 4,000 feet. So I'll put the 4,000 feet there. That makes sense. So far, so good, right? What we want to find is the horizontal distance. That's the ground distance. We want to find this, not this distance. This would be the distance from the plane to the tower, but it says what is the horizontal distance. That helps. That word helps a lot. So the horizontal distance would have to be this distance here. So let's just call that G for ground. You okay for G? G for ground distance? Now, let's take what we have, okay? So it's right triangle trig. Always, always, always start with your angle, right? Start with your angle, okay? Now we do know an acute angle, right? We do, and we've got the 41 degrees. So since we know the acute angle, let's use this side of our nose. So let's go through it. Step 1, pick a non-acute angle. I did that. Pick the 41, right? Step 2, use the given side. Well, that's my 4,000, right? Okay, step 3. Yeah, and obviously we want to solve for G. We don't really care about anything else.
We use 10.
You're way ahead of me, Ben, as always, because you're so smart, okay? Yep. So we're going to have to use G. Ben said tangent, right? From our angle, this would be my opposite side. And from my angle, this is my adjacent. Hi, Miss Hesse. Who are you looking for?
Michael
Oh, Michael, shh, right there. Wilms?
and Sierra.
She's not here. Sierra might be with Mrs. Kelly. All right, so opposite, adjacent. Ben's totally right. You look up here, which one of these three has that ratio, opposite, adjacent? Ben already said it, tangent, we agree? So you set up tangent of theta, right? But that symbol means what? It means angle, right?
Yeah.
So it's tangent of 41 degrees equals my opposite, which is my 4,000, over my little g, right? Now, Ben asked a good question the other day. He said, how do you know which number goes on top? And it's as simple as this. You just have to look. This does say the opposite side's on top of the adjacent, right? Okay, now we have to cross multiply, right? So if I cross multiply, I'm going to bring the g up here, right? So I'll have g times the tangent of 41 equals 4,000, right? And then what I need to do from here is still solve as g times. So I'm going to divide, right? So I'm going to divide by tangent of 41, divide by tangent of 41. And I'm just going to use my calculator. I'm going to put it in just like it says. We're going to go, all right, clear. We're going to go 4,000, 1, 2, 3, divided by tangent of 41. And I get an answer about 4,601, okay? 4,601, and that'd be feet. Now, I always like to ask one last question, which is not up there. Does your answer make sense? 4,600 could make sense, right? I mean, it relates to the triangle, right? And if I had 3 feet, I'd be in trouble, right? That answer makes sense to me, okay? Thumbs up?
Got it.
Yes. If you had 3 feet, it'd probably be about a 89.8.
I agree with you. Totally. Yeah, Ben?
Can I go get some Kleenexes?
Yes, you may. Okay. Example 2. You guys ready for example 2?
It's not going fire.
Okay, a forest ranger is in a 90-foot tower, spots a fire. So always read the question totally first before you start drawing a picture, okay, Tim?
Can I just say that this one doesn't make no sense because if you draw, like, it doesn't say what part of the fire he's looking for, the height or bottom.
With the horizontal distance.
The bottom of the
Okay.
fire.
Yeah,
And it's a
the
square.
horizontal distance, but up to what point on the fire?
I will say the bottom of the fire, because fire can't be that big. Okay, forest fire in a 90-foot tower. It could be.
If it's a forest fire, it can be really big.
It could be. I'd go along with that, Tim. All right, here's my tower, right? Here's the, isn't that a great tower? Here he is, he's sitting in his tower. He's got his binoculars, he's sitting there, and he spots a fire. Right? Okay, spots a fire. Now we've got an angle of depression. So the angle of depression is right there. That's 7 degrees. That's my angle of depression, right? Now, what I really have, and this is 90, right? Yeah, in fact, these two triangles are the same, aren't they? You guys agree?
Yes.
So let's put our 7 degrees also here. You okay with putting the 7 here and here? Because these two triangles are identical, aren't they? So let's use the bottom triangle to solve it. And what we're looking for is the horizontal distance, which we'll call G again, right? Okay. So let's go through it. Step 1. Pick an angle to solve for. With the 7. Let's go with the 7 because that's the angle we know, right? Step 2. Use the given side. That's the 90, right? Step 3. Let's use a side to solve for. How about G? Because that's the one we need to find, right? So from the angle, this would be my opposite side. And this would be my adjacent. I don't need the hypotenuse. Don't really care about the hypotenuse. It's irrelevant. So opposite, adjacent. It's going to be tangent again, isn't it? It's going to be tangent again. Okay. So I'm going to set up tangent. Tangent of theta, but we know our theta really means angle, right? And our angle is 7. Tangent of 7 equals my, according to that, it's my opposite, which is my 90, over my adjacent, which is G. Okay, and then we'll have to do the exact same process as we just did. We'll multiply up the G, put it there. G times the tangent of 7 equals 90, right? Multiply it up to G, put it right there. Okay, then we'll divide by tan 7, divide by tan 7. So G is equal to 90 divided by the tangent of 7. 90 divided by tangent of 7 degrees. And I get about 733. Whoop. Yeah, so we'll just, let's do it. It's 90 divided by tangent of 7. Yeah, how about we go 733, huh?
That works.
And that does make sense to me because the fire's far away, right? Thumbs up so far? Okay, thumbs up. So trigonometry isn't necessarily hard. The directions are there. I think you guys can get this. Okay, turn the page. Okay, here we go. All right, we got 2 more. Okay, number 3, a regular pentagon. Okay, let me go ahead and draw a regular pentagon. All right, a regular pentagon.
Can you throw me that nifty shape maker?
I will. I'd be happy to share my template with you. Okay.
No, what?
I might even have a couple of other templates for you guys. That one does not have a. Well, I guess I'll share. That one's got. This one doesn't have a pentagon. Okay.
There it is, a pentagon.
Hold on. Might even have another.
I want to.
Nope. Yeah, I got a little. This one's got a little. No pentagons. Okay. All right. So it has sides of 12 each.
Oh, did you? Oh, sorry.
All right. Here we go. So 12 each. Now, I want to find the area of the pentagon. So let's do a little bit of thinking. This one's a little bit harder. This one's going to take 3 or 4 different steps. It's also going to take some other kind of math to do. So first of all, if I take a look, that I can divide this pentagon into 5 triangles, right? And each of these triangles, these 5 triangles, are equal to each other, right?
Whoa.
So let me real quickly superimpose one of these triangles, okay? So we've got this triangle here, right? I'm going to superimpose that triangle. Kind of make it here, okay? That's 12, right? So, all right, if I can find the area of this one triangle, multiply it by 5, and I get the whole thing. I'll say it again.
It looks like an equilateral triangle.
It's not, though. It's not. If it was a hexagon, you'd be totally correct, okay? So here's the thing. If we can find the area of this one triangle, multiply by 5, we get the whole thing. Does that make sense? So what I'm going to do is this. So I would like to find this angle right here. I would really like to find this angle. And there's 1, 2, 3, 4, 5 triangles in this circle, right?
Yes.
So if I take 360 and divide it by 5, right? 'Cause
Two.
I would get 72. So I know each of these angles are 72, 72, 72, 72, 72. Okay? Now, so I know this angle is 72, but the problem is that I need a right triangle. I need a right triangle. So I can take and then do another little divide, and I'll make this into a right triangle. Okay, so now let me take a look at just the right triangle. So over here, I'm going to just look at this right triangle over here. Okay, let me highlight it. So what I have,
36 degree.
you're way ahead of me. I like that. Okay, so let me take a look at this triangle because I need a right triangle. To do right triangle trig, I have to have a right triangle. So Tim's correct. This is a 36 degree angle, and this is a 54 degree angle. Okay, 36 degrees because I took half of 72. Okay, 54 degrees because 90 minus 36 is 54. Okay, I know this is 6. Okay, now why am I doing all this? Well, I know that to find the area of a triangle, right? Area of a triangle. So why I'm doing all this for what reason? Well, the area of a triangle is equal to 1/2 base times height, right? I know the base of this triangle is 12, right? Okay. I don't know the height. I don't know the height. Okay. So to find the area of this triangle, I'm going to go, all right, that's 1/2 12, but I don't know the height. So by setting up my right triangle, I can get the height of the triangle, right? Okay, so the height of the triangle, let's see. Can't use Pythagorean's theorem. I can't. But I can use right triangle trig. So step 1, pick an angle to work with. You could either use the 36 or the 54. Just a hint, the 54 is easier. Both will work. Okay, so you can pick either angle. Either angle's fine, but I just know that the 54 is easier. So I'm going to pick the 54. Okay, step 2. Use the given, why is that 54?
I said, why is it easy?
Because you don't have to divide. Just multiply straight up. You'll see. Does that make sense, Tim?
Yeah.
So there's my given side. This is the side I want to solve for. So from the angle, opposite, adjacent is tangent again, isn't it? So I'm going to set up tangent of my angle of 54 equals my h over 6. Tim, now you see why I like that one better. Because all we just multiply straight up and get the answer right. It saves me a step, right? Okay? So multiply up by 6, right? Multiply the 6 up. Put it right there. 6 times the tangent of 54 will give me the height of the triangle. Now we're not done. This is a pretty good multi-step problem. I like it.
Wait, why do we use the equation? Because I don't see where we have the opposite.
We don't. That's what we want to find is the opposite. But we do know the adjacent.
Wait, why wouldn't we just do... But you don't have the hypotenuse either.
Right. So let's do it on my calculator. 6 times tangent of 54. So I get about 8.26. Okay. So the height is about 8.26. Okay. Now we're getting close to finishing this problem. We really are. Okay. So we want to find the area of the Pentagon. Let's go back to what our question is. Our question is simply to find the area of the Pentagon. So we've got to find the area of the Pentagon. How are we going to do that? Let's back up. Find the area of one triangle. Find the area of one triangle, right?
8.26 times 6 divided by 2 times 5.
Okay, so area of the triangle. So we're going to go area of this triangle. Area of this triangle is going to be 1/2 its base, which is 12, times its height. We know what the height is, 8.26. Okay, so I'm going to use my calculator. I'm going to go 1/2 times 12 times 8.26, and I get an answer of 49.56. That's the area of a triangle.
49.
Okay, depend.
I use the answer, not typing in. That's what you chose.
And your answer is better. And you're better.
Better.
Now, but that's not our answer. That's the area of one triangle. That's one triangle, right? That's one triangle. So if we want the Pentagon, right, let's multiply this times 5. Okay, so then times this by 5, times by 5, because there's 5 triangles, right? And we get a grand answer of about 247.8 centimeters squared. There's my answer, okay? And Ben, your answer is going to be more accurate than mine. Just because you're better than me, aren't you? Yeah. Okay, that's a little bit harder. Can you do one like that on Friday?
Well, I got 247.8, that's right.
That's exciting.
Okay. Now, last but not least, example 4, okay? All right, so Landon gets on a Ferris wheel and is rotated 200 degrees to load the next way. Shh, 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 shh. Gotta listen.
Thing, height, and then split that.
Okay.
I'm
Here we go.
explaining it to him just so.
You were, that's why. Okay, so Landon gets on a Ferris wheel and is rotated 200 degrees. So from here, 0 degrees, all the way around is 200 degrees, okay? The wheel has a diameter of 42 feet. So this is 42 feet, right? And the total height of the ride is 50 feet. So this is 50 feet. So if this whole thing is 50, the diameter is 42, which means this is 21 and this is 21. Okay? Does that make sense? Okay. The whole ride's 50 feet tall, the diameter 42. So I know the radius of the wheel is 21, okay?
Wait,
Right.
and then we just have to wait.
So now what we want to do is find a right triangle. We really do want to find a right triangle. So my right triangle is going to be right here. Do you see my right triangle? And let me highlight that. Here's my right triangle, okay? We need more information. So what I also know is I'm going to go 200 degrees. 200 degrees from here to here is 200 degrees, which makes this angle 20 degrees because this angle is 180 to go 200 degrees. Okay, you with me? 200 degrees, so my rotation is 180 plus 20, right? 180 plus 20. So if this arc is 20 degrees, and this angle here is also 20 degrees. This one's a little bit harder.
Slow down.
This one's a little bit harder. This is a good problem. Well, that's because I'm a lousy artist, okay? Will you accept that price?
Yes.
Okay.
No.
I'm a terrible artist.
Sorry,
This way.
Ben.
So, what I want to do is this. If I can find, let me erase this 21 for a second. I'll get rid of this 21. Get rid of this 21 because I don't really need the 21. Because he's not all the way at the top, right? Landon's not sitting up here. He's sitting here. I need to find this height. Let's call this H here. I need to find H, okay? I do know land is at least 8 feet. Because from here to here's 8. Here to here's 8. So land is at least 8 feet plus 21 feet plus the height from here to here, okay?
I'm just kind of like confused.
Okay, I'll slow it down. Okay. So, Ben, let me back you up, okay?
Okay.
From here to here's 50, right? See it? You're watching it from here to here's 50.
Yes.
This is 42, so this has to be 8. You okay with that? This from here to here's 50. All the way to the top is 50. This is 42. This is 42. So the little stand is 8, okay? So to get to land, we got to go up 8 feet. Then we got to go up another 21 feet. Then we got to get this height right here, okay? Okay. Now to get this height, let's just take a look at this triangle. So let me superimpose my triangle over here, okay? And again, price you right. My art is terrible because that does not look like 20. It looks much bigger than 20, doesn't it?
Yeah.
Remember, Mr. Davies is a lousy artist, okay? The only reason I got a B in art was because my aunt was the teacher, okay? That's a true story. So, I need H. Okay? Now, I know this length. It's like a clock. If this is the radius of 21, it's like a clock. If this is 21, this also has to be 21, right? Like the radius of a clock. Okay, 21, that has to be 21, okay. Hey, we're ready to finish this problem. It's a complicated problem, isn't it?
It is.
It's a good problem.
Extra on the
We
test.
certainly have some kids in here that this problem's a good problem for, okay?
Extra or like a question?
Well, we'll have to wait and find out.
Oh, boy.
I think you guys can do this problem. I do. So now, can you find h? Sure.
Yes, we
Yes,
can.
we can.
Step one.
First, we need to find the other angle though.
No, we don't.
Well, we can.
We have the acute angle.
We can. So,
So, okay.
step one. What's our step one? What's step one?
20.
Okay, we'll use our 20. Step two.
21 and
It's
8.
at 21.
And step three, the h, right? So we have the adjacent
And the hypotenuse.
and the hypotenuse.
That would be
Cosine.
Cosine, right? So we're going to go cosine of theta, but not theta. Theta is my angle, right? Right, Bijou?
Then we would use 20.
Is equal to my adjacent, which is my h, or my hypotenuse, which is 21, right?
Yep.
So then we'll beat the
Multiply up to 21. Well, 21.
And then you have to go to 21.
We'll use our calculator, right? 21 times the cosine of 20. And I get about 19.7. We're going to be able to rescue poor Landon. So to get Landon,
Wait, but we never said anything about rescuing.
all right, either way, 8 plus 21 plus 19.7. And we get an answer of about 48.73 feet in the air. Okay, there he is. All right, now, this came from a different book. So you have a homework assignment. You really do. It's in the computer.